my topic is the introduction to binomial distribution and the Poisson distribution. It's two distribution of the statistics. Okay, in the first part today, we will mainly talk about the binomial distribution, which is the first distribution, and some basic definition based on this distribution. And on the second distribution, we will find that the binomial distribution has some disadvantages. So we should use another distribution to approximate it, to make it calculate more easier. Okay. First, let's see the first part. So the first definition is the probability. I think you have heard that, but you don't know the general definition of that. So first, we should look at an example. We always see from the forecast of weather saying that the probability of precipitation is 40%. So what does that mean? That means the value here is a property of this event. The precipitation here is an event, and the value here shows the property of this event. And we say this value is the probability related to that event. Okay. So it's a relationship using a value between 0 and 1 to define the probability, property of an event. So after we know the probability, we should know what is the distribution here. We also use an example to illustrate that. If we toss a fair coin twice, you know a fair coin twice, so we will get 4. If we consider the order, we will get 4 outcomes, right? Head and hand, hand and tail, tail and hand, tail and tail. And if we don't consider the order, how many outcomes we will get? 3, right? For this one and this one are the same, right? We don't consider the order. And no matter we consider in the order or not, the outcome with each event is 1/4, right? And if we don't consider order, this event becomes one event, and the probability of that is 1/2, right? We plus the 1/4, double the 1/4 here. And we use a random variable x to define those events. After we define the random variable here, we can get a group of events associated with the random variables. So for each event, as the example shows, we can get a probability related to that event. And so we will get a distribution of that random variables, which means this one, right? That has 4 outcomes for each event. The random variable has a probability. Although in this example, they are all 1/4. Okay. So what is a distribution? It's a group of probabilities using values between 0 and 1 to define the probability of a group of events. So if we want to define a distribution, first we should get a random variable, right? A random variable includes a group of events, and we can get associated value. So the main part of it, the first part, is what is a binomial distribution. Let me see an example first. So, a same fair coin, okay. If we toss a fair coin 10 times, then we use the random variable to define the number of heads in the 10 experiments. Okay, what does that mean? So, how many outcomes would you think to show in the random variable? Any answer? How many outcomes will x get? I mean, how many events will the random variable include? It's 11, right? From 0 to 10. Right? Yeah, 0 head to 10 heads. So there are totally 11 outcomes, which means 11 events. Okay, so in this particular occasion, we say x is distributed with a binomial distribution with the sample size. Sample size is the events we have. Okay, so there are 10 events, and 1/2 is the probability for each of the. We toss the coin 10 times. For each time, we have the probability of 1/2. So the probability here is 1 part or a unit part of the total events. We define that probability in the binomial distribution. And if we know x is distributed with the binomial distribution of that, we can get the formula to find the value of here. K is from 0 to 10, right? We have 11 outcomes. So K is from 0 to 10. And this formula is a little bit complicated, or I can write a more clear one is okay. In the slide you can see there are something you don't need to care about that, but the constant here is just one way we can define it is we from 10 outcomes to find k outcomes, and the ways we can get them is this number. Okay, in factorial it's 10 factorial divided by k factorial and 10 minus k factorial. That's the way we can get from 10 get k outcomes from 10 outcomes. And that's the first part. And second part is 1 over 2 to the power of k. This one defines the probability of your success. I have said that for each part, you get a probability of 1 over 2. And there are 10 parts in the example. So if we get k parts to success, we have this number to define the probability of success in the whole events. And this one, of course, the fails, right? 10 minus k is the fails you got. It means you get the tail in the coin. So, and 1 minus 1 over half, although they are the same, but if this one is a p and this one is a 1 minus p, they are maybe different. So this one calculates the probability of fails in your total events. And that's an example for a binomial distribution. And in general, as I said before, if this one is p, and the 10 here is we toss the coin 10 times. If we toss coin n times, we don't know what is n. Yeah, we know, but we don't use a constant number for that. Then the formula for it, that is okay. The formula is here. Is in general for the n. In the example, we toss the fair coin n times, and the p here is with the probability for each toss. We get the probability of a pack is p. Okay, and 1 minus p is the tail. So this one calculates the fail, and this one calculates the success, and this one is the way we can get the success. So in this total 3 parts, we can define a binomial distribution by that formula. And here is a question. As that formula shows, if n is very large, for example, 1 million, okay, and I want to get probability that the success number is, for example, 100, then for the first part here, or you can just say here, if this is 1 million, the k here is 100. 1 million factorial is a very large number, right? And also 100 is not a small number also. So it's hard to calculate. So what should we do to define or to calculate the probability of that location? And that's what I would talk about in the next part, Poisson distribution. It can approximate the binomial distribution if the n is very large, and we can calculate it very easy. Okay. And okay, that's for my first part. Is there any questions? Okay, thank you very much.